be there. So here, that is the syllabus will be there. That is the domain and background of reinforcement learning in games. What are the challenges that we are applying in reinforcement learning to games? And reinforcement learning in robotics challenge will be there. Reinforcement learning foundation of robotics will be there. Trackability, simulation, representation, and prior knowledge. So all these things we will discuss in that unit 5. So first we are going for that is the challenges of applying reinforcement learning in that games. First we are considering that is what will be the challenges of applying reinforcement learning to the games. Now we will go through. So applications of reinforcement learning usually have rich domain knowledge about games, which can aid representation design. Domain knowledge come in many forms. What are the different forms will be there? Knowledge of the rules, the model of the game, what model of game is doing, and information is relevant or not, knowing what and gameplay information from where, that is the knowledge of rules and other things you will get that is predefined will be there. And you will get that another way will be there. What are the human experts that are experts in that specific game? You will get information from there. They may come from any advice will be there, rule of thumbs will be there, relevant features of the games. So from these particular sources, you are getting that information. And you may be getting that this information from databases of the recorded games, from where you are also getting opening books also there, and games databases will be there. So these all are the sources from where you are getting. And beside this, we are having that rich evaluate feedbacks will be there. In many cases, the agent get more evaluative information than just the reward signal, but less than full supervision will be there, like a decomposition of the reward with respect to sub goals. For example, in a combat of teams, beside the goal, reward, victory, defeat, each member get individual feedback, remaining hit points, amount of harms. In fact, okay, I will take that one example will be there. Maybe that you will be here that one game is there. The game name is Contra. So in Contra, basically what happened, we are having that separate levels will be there. In that levels, what will be there, whatever this particular agent will be there. So this agent is going to clear these levels. In that levels, some hurdles will be there, some enemies will be there. So what happened, this in that level 0, the hurdle will be less than 1, 2, 3, 4. So what happened when the player is playing with that 0 level, it is that we are having that various situations will be came now. Just like that we are having that this will be, we are starting from this one, this will be our agent will be there, agent will be moving like this direction, and the enemies will be there. But it may be possible like if the agent will jump there, any other options or situations will be there. Sometimes you will not win the game, but what happened, you will having that you will discover that the new situations or the new places will be there. So that is known as the rich feedback for that this one, for example, that combat of teams and other things that we have been discussed there. So this is basically an example that we are discussing for that in relevant to the rich evolution feedback, right? Next one, what are the features of extraction and abstraction? That is the important thing will be there. We are having the tabular representation will be the tabular representation, you know very well na? In the form of rows and columns will be there for games with that they are having that discrete states will be there. The trivial feature mapping of renders will be there. A unique identifier will be there, each state corresponding to the tabular representation. What happened, I will give that one game is there. In that game, what happened, that we are having that these some boxes will be there. Okay, these are some boxes or the grids will be there, and the agent will be there. If agent is moving there, if some black hole is there, so it will be blast, that will be blast, and your agent will be died. So what will be your target? Your target is going to that upper state whenever it was moving in that this direction. So if that it was not touching that this one, whatever the black spots will be there, and black spots are not seen by you. So what happened, you will be reaching that this thing. So here that we have required that this tabular representation. where the particular pitch is having this one. So next one, the performance of dynamic programming based methods depend on the size of state and space. What is the size? That is the important thing. What will be the size of the state space will be there. Usually that we are having the tabular representation, and that is your intractable will be there. Next thing, we are having that state space sampling methods will be there. We are having that UCT will be there. What is UCT will be there? UCT is that is your upper confidence bound applied to tree. What will be there in that UCT? We are having this is a popular algorithm that deals with the flow of Monte Carlo tree search. Basically in UCT, what happened, what we are doing, you will be see that thing in that your Python also. UCT is also there. What basically that we are doing with the UCT, in UCT, we will be starting with the that first we are going for, that is the selection. Second one that we are going for that expansion. Selection will be there. Next will be your that will be expansion will be there. Third one that we are going for that the same thing. We are having that simulation will be going on. And next thing that we are going for in it, that is back propagation. So these all things will be covered in that your ECT. Okay, and remain trackable as they, you are having that some games. Okay, I will just give you one example. In that whatever you are having, that two platforms will be there. One is Unix or the Linux based operating system or Unix platform, and second one will be the Word that is Windows platform will be there. The Windows will be the proprietary platform, and it is the open source platform. In Unix platform, you are having n number of games will be there. Your whole life will be covered. But whatever the games that will be defined in will be developed in the Unix platform, you will not cover up. That is only add-on that the information that I am giving you. So the particular that next point, the trade-off, the lack of stored values and the lack of generalized by increasing pre-movement decision time. Pre-movement decision, that is what will be the pre-movement decision time will be there. If you are moving from one position to another position, so that you will estimate now if we are going by that we are having, okay, I will just discuss that thing. You will be there, okay, and you are having your target will be there, and we are having that different ways will be there. You will be going to there and you will be going to there or something. So you will get now if you are choosing that this path, so what happens that you are reaching that your target will be fast. So that is the pre-movement decision time will be there whenever you are going for in particular movement will be there. So you know that what decision in that particular that time movement, what that decision you will be taking, that is the pre-movement to your decision time will be there. Next one, we are having that expert features will be there. We are having that game situations are commonly categorized by numerical quantities will be there, and they are considered by the relevant by an expert will be there. Examples of such features are material sense in such. We have just to go through with the chess game will be there, and liberties in Go will be there. Number of holes in Tetris will be there. These are some examples of that expert features will be there. It is also common to use binary features. The presence of pattern will be that we are having chess or Go game will be there where we are using it. We are having relational representation will be there. Relational, object oriented, and indicative representation are similar. They assume that the game situation can be categorized by several relevant relationships between objects. What will be that? That means technically a special case of expert system, expert features, and each relationship involves a few objects only. What that means, that the relational representation means if the particular movement from an agent will be going from this place to this place, so what happened to movement from this place to this place, we have required some actions, and there will be a series of that will be there, actions will be there. This is your source and this is your destination will be there. So that will be represented by the relational representations, where that the relationship that if you going for this action, then this relationship will be among that whatever the other objects that will be associated, they will be interacting with them. Such representation may be used directly for the value, this is value function approximation, or by some structured reinforcement learning algorithm that we have been studied, that value function approximation and the structured reinforcement learning algorithms in the previous sections. Now we are having that is the state aggregation and clustering will be there. In that state aggregation and clustering, what happens? In some cases, it is possible to enumerate and aggregate ground state directly. What will be the ground state means? You are practically in chess. What happens if your movement will be there? You know very well now. If that is king is there, so king will take one step, and queen will be there. It was going for that. We are having that different directions will be there. So queen can move in that different directions. So it is more commonly to perform clustering in some previously created feature space will be there. Cluster centers can be used either as a cases in case-based reasoning or high-level discrimination of state space will be there. What that means, that clusters, what will be the clusters? Cluster means that we are having the homogeneous elements in that one place. Homogeneous elements will be there, and we are having this cluster will be there. In that cluster, what we are doing, the particular that whatever the hurdles will be there, what are the actions will be there, what are the movements will be there, that will be specified that this cluster will be there. So that all these things will be we are using for these clusters. Just cases will be that case-based reasoning or high-level disposition of state space we can use in that these clusters. That depends on the particular game which we are going for. Then we are having the combination features will be there. Conjunction features requires the that is conjunction. You know about the conjunction. What is conjunction? The conjunction features requires the combined presence of several binary features. While more generally, we can take the combination of features while logical formulas are there. With the help of this, we will be do. And simple what they are doing, they are having that non-linearity in the inputs will be there. So they are especially useful to use with the linear function approximations will be there. So combination features are also a common subject of automatic representations of search techniques that we are using. Then now that automatic representation search techniques will become, now what happened in that your that is artificial neural network or RNN. What we are having that hidden layers will be there. So hidden layers of the neural network define features mapping of input space. So method that use neural network can be considered as the implicit feature construction method. So this method will be known as implicit feature construction method. What will be going on that in the neural network? What happened? We are having that some input will be there. Then we are having that again that some hidden layers will be there. And in after we are having, so something will be going like that. We are having these things will be there. And in again that this will be your input, this is your output, and these are your hidden layers. These two are hidden layers. So what will be the role of these hidden layers will be there? They are performing some functions will be there, and this will be there. So this is the implicit feature construction method that was defined in that 1995. So sorry, that is T0 1995 reports that TD Gammon learned interesting patterns will be there corresponding to the typical situation in that is the backgammon. This is a game where they have been derived. So we are having that Moritati and McLuhan in 95 uses that here from this 1995. Basically, we are going for that using that AI, artificial evolution, to develop neural network for Othello position evolution and manage to discover advanced Othello strategies. Othello positions will be that there that we are assuming that that is we are say simulation environment where that the particular object where what will be the movement will be there. So that is then Othello that will be position. Just like that we are having that what will be said that aircraft that is jet fighter training will be there. So if we just okay, we are having flight simulator. In that flight simulator, what happens if we will be trained at the particular training on that first flight simulator, and then we will go ahead with that the original flights. Then what happened? Their efficiency and their learning will be good. Instead of if we are going for directly deploying to the flight for that takeoff and take on and running the flight, so it may be the loss of that particular that flight as well as the human loss will be there, right? So the morph system that is Gord and Levinson in 1992 extract generalized patterns from chess positions, just like Levinson and Webin in 2001. Both approaches, they are having some weights of patterns will be there, and we are using by this with this mechanism will be there. We are using this one, and in that Finkelstein and McQueen 1918 modify the approach to search for state action patterns will be there, and the difference of these value functions and this will be later does not look at for that is only the history that we are going for. Just add these things. Okay, in that when we are going for learn, that is implicit feature of construction will be there, in backgammon game will be there, what we are getting for the neural network, auxiliary positions and other things will be there, and chess we are what we are going on. So the whole things will be getting in that automatic feature construction. So now a general approach for feature construction is to combine automatic features. What will be the automatic features we are having into the large conjunctions or more complex logical formulas? That is the general approach that we are used for for the construction of these automatic features. So the Janet system of Packard and Otakov in 1922 constructs features of Othello from a set of automatic formula of first order predict logic. That is the first order predict logic will become calculus will became in 1992. Using this, what will be the decomposition, abstraction, regression, and specialization operators will become. So whatever these features are created, that is iteratively by adding whatever the features that help from discriminating between good or bad outcomes. Some books they have been written that that is the good position or the bad position. The features will be known to cut that one thing will become, that is the pronoun will become, and the meaning of that pronoun will be that is to cut down that branches. If we are having some games will be there now to cut down the branches will be there, and they are using how they will cut down, they are using a linear valuation function for the same. A similar system for Yudkov and Tikov in 1998 construct new features by checkers, that is conjunction of simpler Boolean predicates will be there. So now in that exploration, what will be going on in exploration? A central issue in driving that agents towards an optimal solution that will be going on. In most game applications, the algorithm is expecting the game dynamics in backgammon or the opponent do the exploration training against a variety of opponents or just hope that it will be well. What will be going on that in every game what happened, we are expecting that what will be the opponents will be there, we will defeat that your all opponents will be there, you will defeat that your all these opponents will be there, and whatever the training and other things and whatever the rewards you are getting, maybe that you are getting some weapon with the help of that reward, or you are getting that some coins will be there, or you are having that some additional features will be add on your profile. So that will be going on. We will overview the choice and aspect of opponent selection and concrete here. The agent's own role is enforcing variety. What that means, that depends on agents that what kind of that they want to play a role for that selection, what will be the choice and other things that will be dependent by the particular agents. Now, we are having that Boltzmann and greedy action selection is the most commonly that exploration. We are using that these two concepts where technical terms will be there. We know from the theory of finite when we have studied that MTBs that much more efficient exploration method will be exist. But it is not known yet how to extend these methods to model-free reinforcement learning, which function approximation, which covers large part of the game application. Till now, we are having that we have already studied that two type of MWPTs will be there, finite and infinite will be there. So what will be going on there in here, that what will be that your finite MDPs and infinite MDPs will be there. But right now, what happened? What will be that we are working on? We are having that working on only on finite MDPs. But till now, these models, whatever the reinforcement, model-free reinforcement learnings with function approximation, that may be covered that large part of your game application. Still, that this one model-free reinforcement learning or that infinite MDPs, they are in evolution phase. We are having some real that is augmented virtual reality games are there where up to an extent we have achieved this target. Then again that UCT concept will become, we have already discussed that upper confidence bound applied to trees will be there. We are having that that is the selection, expression, simulation and backpropagation will be going on. And beside this, we are having that other Monte Carlo tree searching algorithms that will be handle extraction in somewhat more principled way, maintaining confidence interval representation, the uncertainty of outcomes, and the apply the principle of optimization in the phase uncertainty. So these will be there. Basically, you will learn that what will be that UCT and other Monte Carlo algorithms, search algorithms will be there that we are using for that exploration purpose. Then when a generative model of the game is available, which is the case for many games, even classical planning can simulate exploration will be there. This happens that in TD leaf and TD scrap. Now two terms will become, one is your TD leaf and one is your tree scrap will be there. So what is that TD leaf? That is temporal, difference learning will be that we are using for TD leaf. And for tree step, what is tree step? That is tree based computing will be there, where we are having that promising directions will be there. But these all things are part of that your data structure where we are studied that tree. Maybe here you have studied that RTL, TTL, and these things, all these things will be came in that particular point. Next is that whatever that we are having that evolutionary reinforcement learning approaches will be there. What are these things? We are exploring that particular parameter space in a population based manner, and genetic operators like mutation and crossover ensure that the agents try sufficiently diverse. What that means, we are having mutation. Why the mutation will be required? The mutation means that you are having one thing will be there and you are muted to another, same copy will be there. What will be that same copy meaning will be there? If you are in a situation, in that situation to overcome from that this point to this point, this is your source and this is your target. So some actions will be performed. If you are not performing these actions, or you are not having this percentage of power, or that points will be there, so you can't go ahead with them. So for this one, we are having that resilient simultaneous permutation stochastic approximation will be there, that we are using for basically for the parameter space, but it uses local search instead of maintaining a population of agent. Because why the local agent will become? Because that we are working here with the finite MDP. So in finite MDP, what will be happen? That whatever the steps and the situations will be already finite. Okay. So here, basically in that exploration, we are basically dealing with the data structure concept. Data structure, and basically in data structure, we are focusing on tree. Then the next topic will be the source of the training data, from where we are getting the source of training data will be there. For games with two or more players, the environment of the learning agent depends on that other players will be there. The goal of the learning agent can be found by that Nash equilibrium. What will be the Nash equilibrium? The Nash equilibrium, basically it represents an action profile for all that whatever the players that will be available in any game, all players in the game, and is used to predict the outcome of their decision making and interaction that was going in the that specific game. So a best response for play against the fixed that opponents will be there, just performing that against the set of strong opponents will be there. So we are using that Nash equilibrium for that that is for the learning for that agent. However, on the other end, if we are going ahead, so what happened? Learning can be very inefficient or completely blocked if the opponent is much stronger than the actual level of the agent. That already, that if you are having that, if you are not having that, if you are having in that some what will be there, if you are having that level will be there, level 1, 2, 3, so level hardness will be increasing. So level it will be that when the level that this one complete of that hardness will be increasing, what happen, you are having very less time to learn and other thing as compared to that. If your opponent whatever the in the what happen, if the level will be increasing, so the hardness of that game will be going on. So what happen, your opponent will be that more strong in that particular that this level. So what happen, you are having that very less or inefficient for that learning of that new things will be there. So all these strategies that a beginner agent tries to end up with the loss with high probability. So the reinforcement signal will be uniformly negative, not providing any directions for the improvement. In another note, we are discussing that opponents have to be sufficiently diverse to prevent the agent from converging to local optima. For these reasons, the choice of training opponents is a non-retrieval question. That is not a too much important thing. Only these things, 1, 2, 3, 4. These 4 things will be important there. Then the another source of training data is self-play. Self-play means you own play the game. What will be that just like that, if you are infant kid, so you will start your that for first step, then you will be just going for walking the things, then you are running. So what you have been that learn from itself now. So self-playing, what will be that is most, it is was this particular method is the most popular training method. According to whatever the experience will be there, training is quickest if the learner's opponent is roughly equally strong, and that definitely holds for that self-play. But second reason for popularity will be there. There is no need to implement or access a different agents. There is no need for that accessing for different agents. With roughly equal playing strength, you will be go ahead with that you are learning. The major the problem with the self play will be that the single opponent does not provide sufficient exploration. What that means, if you are doing that the self exploration will be going on, self play will be going on, so it may be possible you are going always that you are having that the level will be that less hurdle, so you are having win situation will be going on. But there will be a drawback that you can't explore that what will be that the other possibilities will be there where you will be go ahead for that other this exploration will be blocked there. Next will be the lack of exploration may lead to situations where the poker agent is trapped in self-fulfilling prophecy will be there. Suppose that a state is incorrectly, so you will be estimated you are in bad position. Because of that, the agent folds or that lose the game. So the estimated value of state will be go further down. So what that means, if you are having that lack of exploration or you are not well defined at how to, you are not aware about that path, you are not aware about your actions, you are not aware about that if where which direction you want to move, so what is your strategy to that win that particular game will be there. So these are some consequences that that will be with the help of in that domain of self play. So we are having alternative self play will be there. The agent may be tortured by set of different opponents with if they are having increasing. If you are playing self play, so you don't know now where will be the hurdle will be there and where will be the enemies will be there. It may be possible that you will be there and you will be that covered by that whole side that enemies will be there. So on that what will be there? They will torture whatever the power or whatever that the percentage of that rewards you are having, they will snatch that all these things, or even that you will be died on that particular stage. For more popular games like chess or go will be there, such a series of opponents can be found on game servers. Game servers will be there that match players based on their playing strength. We are having online that this time online games are there. In that online games, what you are having right now, you will that make your team, online team, and in that team whatever that the players of that cricket teams of Indian teams and whatever they are having the expertise for they are having some expertise now, so all these expertise will be put it down that a particular specific player, and you have been just pick up that these teams and you will play with that computer or other opponents that will be good. So such a pool of players is not available for every game. And even if it is, games are typically much slower, reducing the number of games that can be played. But on the positive side, what happened? Agents trained by torturing are typically significantly stronger than ones trained by self-play. What that means, if you will be, that will be the learning by that incident will be going on. If you have been that put down that in huddle, and you will be that tortured, or you are in that awkward, that is the awkward situation where you will be, and you will be died on particular situation in that particular circumstances. So next time you will be known, if you are having in that particular situation, it is better to fight within that some strategy, or you will be take that some other option, so you can just eliminate, or you can just bypass this particular stage or that particular that event. On the positive side, trained by torturing, so okay, that is completed. Then we are having that other source of that training will be there. We are having lesson and practice will be there. What will be lesson and practice will be there? We are having that that resource expensive will be there. We are having tutoring games will be there, which is followed by the periods of self play will be there. So with the help of that lesson and practice, you can go ahead. And the Turan that 1995 trains neurochess by self-play will be there, but no enforce that exploration will be there. Each game was initiated by several steps will be there with the random game and the game database they are using for the same. This way, the agent started self-play from more or less random positions will be going on. So learning from these observations of game database is cheap way to learning, but usually not leading to good results. The agent only gets the experience good moves, which were taken in the database games. So it never learns about the value of the worse actions or about the situations where the same actions are bad. What that means, whatever, if we are using that game databases will be there. In game databases, what happens, we are having that specific inputs will be there, specific actions will be there, specific moves will be there. So you are not having, if you are having the real-time games will be there, or virtual reality games or community reality games will be there. So actually what happens, you will be explored at new positions. You are having that new ways to strategies you can be learned. But if you are using with only that whatever that the game database will be there, so that is not a good concept to deal with that for that this one in the source of training. So dealing with the missing information, if how to deal with the missing information will be there. So we face that information in both, we are having that the classical and computer games will be there. For example, hidden cards in poker, partial visibility of first person shooters, or fog of war in real-time strategies. So that they are comparative with the, that is the comparison they have been done. And between that classical and computer games. One of the often used approaches is ignore the problem and learn reactive policies based on that whatever the current observations that you are going on, that you will be there. While TD like will be there, that TD leaf temporal like will be there. In that method diverse that we are having that some of these Monte Carlo estimations and other things that we are using in it. The applicability of the direct policy search methods includes your dynamic scripting, cross entropy policy, and evolutionary policy search. That is the partial observability. These all these we are dealing with that we will be there. But whatever these assumptions that we are dealing with the missing information, that will be means that will be different among the nature of game. If you are having that online game will be there, if you are using some game database will be there, if you are using real time. So the missing information will play that different role in the different types of games where you are consecuting that these things. Then we are having that dealing with these, we are having that Monte Carlo sampling is one method. In that method, however, that what will be the problematic and adversarial search, we are using that Monte Carlo sampling for this dealing with that what is that you are missing information. We are having that value of information, the decision in that particular decision making, and this will be their value of information when a move is preferred, because that is only the things they have been discussed about, that Monte Carlo sampling will be there. Then we are having that another algorithm, min-max algorithm. We have already studied that for this one. We are having that bridge playing program will be there. In that we are using that MC sampling will be there. So these are some sampling method where you can get the missing information. You will be having, you will retrieve this missing information with the help of these mechanisms. So the concept of that is the counterfactual regret will be there. In that we are having that anglicious to MCTs will be there. That is cancel opponent will be the value calculation will be there. When we are combinations of these CFR, we will discuss these CFR and these things in that unit 4. We are having one chapter will be there. We will dealing with at that time this thing, dealing with these things. But currently you are having sufficient things with this one, sampling methods and min-max strategy. MC sampling will be there, and the agents will be having TD like method, Monte Carlo method. So you are having sufficient that material you will write up on that particular topic. So that's all for today. Tomorrow we will discuss about that is the next topic. We are having simple thing will be there, opponent modeling will be there. I will just explain that what will be going on there. In opponent modeling, what happened, the behavior of the opponent is the kind of hidden operation will be there, hidden information will be there. How that you will just predict that thing ki, what will be the move of opponent based on their past observations from that previous games will be going on there. Opponent modeling is an important augmentation of multiplayer reinforcement system will be there. So Nash equilibrium and vertex learns, these all things we have been discussed. So that will be dealing with that we are having this Probimax will be there that we are using in that chess. We'll discuss these all these things later. Okay.